In this lesson we will try making some practical things with netcode for game objects. But before we do anything I have to explain some core concepts. Before we only made scripts that ran on one device using mono behavior because we were making single-player games. Now we will be using netcode for game objects network behavior because we are making a multiplayer game that runs on two or more devices called the client and the server. So since network behavior scripts run on both the clients and the server, how do we make it so it only runs server code in some places and only runs client code in other places? For this we have an isServer boolean. When we use an if statement with isServer set to true, only the server runs the code inside the brackets. And when it is set to false, only the client runs the code inside the brackets. If we don't use the boolean, both the client and the server will run the code. Here is an example of what our scripts with network behavior will look like. Note that we can just write isServer inside the if statement without setting it to true for our IDE to check if it's true, and we can just write an exclamation mark before isServer to check if it's false. Now that we know how to exclusively run code on the client or server, let's talk about how we can send messages from a client to a server or from a server to a client. To send messages from one computer to another, we use the RPC attribute above a method which makes the code inside a method execute on the other device. We can use RPC, send to everyone, to make the code execute on all the computers. RPC, send to not server, to make the code execute only on the clients. RPC, send to server, to make it execute only on the server. And RPC, send to specified in parameters, to make it only execute on one client. Here is an example of a client making code execute on the server using the send to server RPC attribute. And here is another example of a server making code execute on all the clients using the send to not server RPC attribute. Note that we can also send information from one device to another by using parameters in the methods, like in this example where the server sends an integer value of 100 to the clients. Now let's talk about network variables. Previously in mono behavior we used stuff like integers, strings and booleans. In network behavior we use network variables that can be read by all devices because normal integers, strings and booleans are not readable without using an RPC. Here is an example of a network variable integer. Note that we cannot use strings with network variables, as strings can range to have 2 billion characters. We can however use fixed range strings like fixed string 32 bytes and fixed string 4096 bytes from the Unity.collections namespace. Also note that we have to use fixed range strings inside of RPC methods as well, like in this example. Now let's talk about one of the new methods available from network behavior called onNetworkSpawn, that works like a start method but gets executed every time a client connects or when the server starts. It is useful for syncing values from the server to all the clients, where we can use an invoke repeating method that will execute a method every 0.01 seconds. Here is an example of an onNetworkSpawn executing an invoke repeating method. We avoid using the update method for syncing values because it runs once per frame, like 60 times per second at 60 FPS, which can be inefficient, unlike invoke repeating which can control the execution to a constant rate. Now let's talk about how we can start the server or the client. To start the server we can run the following code in the start method when we finish making the project and are ready to build a Linux dedicated server build. You need to then run the Linux dedicated server build on a VPS so other clients can connect to its IP address and port. To start the client we have to execute the following code. Note that for this series of videos, we won't be uploading our Linux build to a VPS. The clients won't need to connect to an IP address and port since the server and client will run on the same machine using localhost. Localhost allows programs on the same computer to connect to each other. We will create a single Windows build with 2 buttons to start either the server or the client. The program will act as the server or client depending on which button is clicked. Now that I'm finally done explaining the core concepts, let's start the tutorial. This is the first thing we are going to build. We have a server here and 2 clients that can increase the value of a network variable. Let's start by making a scene with the Text Mesh Pro text object. Start by importing the Text Mesh Pro essential resources. Now add a Text Mesh Pro text object to the scene. Give it whatever name you want. I will name mine text. Then empty out its text field. Then anchor it to the middle center. Make sure you hold Shift and Alt before tapping on it. We will use this text object to display the value of a network variable. Now let's continue making the scene and add 3 more buttons to it. Start by making a button. Now change its width to 300 and its height to 120. Change the text field to Start Server. Let's also make the text bold and set its size to 48. Now rename the button to Start Server button. With the button selected, press Ctrl and D on your keyboard to duplicate it. Then change the text to Start Client. Rename the button to Start Client button. Now duplicate a button one last time. Set the text field to increase by 1. Rename the button to Increment button. Make the text size smaller so that it fits in one line. Now hold Ctrl on your keyboard and select all your buttons. Anchor them to the top center while holding Shift and Alt. Now let's move the buttons a bit so they don't overlap. We now need to make 2 empty game objects. One will contain the Network Manager component enabling us to start either the server or the client. The other will hold all of our scripts. Make a new empty game object and then rename it to Network Manager. Then search for the Network Manager component and add it to the object. Make it use the Unity transport. Now make another empty game object and rename it to Scripts. Let's create a script and name it Netcode example on this object. We are done setting up the scene for this example. Let's go over what the Netcode example script will do before we start editing it. First we will add the unity.netcode namespace, then modify the script to use network behavior instead of mono behavior. Next we will add listeners to 2 of the 3 buttons on click events to start the server and client when clicked. Then we will add a network variable integer whose value will only be increased by the server but can be read by both the clients and the server. Then we will use the third button's onClick event to allow clients to increase the value of the network variable by sending an RPC message to the server to add one to it. Let's begin creating the script. Start by double-tapping this region of the script so that it opens in our IDE. Add the unity.netcode namespace. Now change from mono behavior to network behavior and save the script. There is now a network object on the empty GameObject we named scripts before. Add the two namespaces for the button and text references so we can use them. Create 3 buttons with serialize fields. We will add listeners to their onClick events. Let's also make the two methods the onClick events should execute. Let's add the listeners. I will keep the third listener null for now. Let's make these two methods start the client and server now. Let's make it so we can only click one of these buttons once. We can delete the update method because we will not need it. Let's make the text mesh pro UGUI reference that will display the score value. Let's also create a network variable integer that starts with a default value of 100 and is only changeable by the server but readable by both the clients and the server. Let's make a method for the third button's listener which will add a value of 1 to the score. We need to make it so that the code inside this method is executed by the server using an RPC attribute. The method's name needs to end with the RPC suffix. We will make an onNetwork spawn function now so we can execute an invoke repeating method only once by the server. For that we need a bool. Let's also make the method that should update the text that will be executed 100 times a second. This method needs to work on all the computers, so we used an RPC send to everyone attribute. Don't forget to add an RPC suffix. It's better to write our code below the base code. Make the delay 0 seconds and make it run every 0.01 seconds. Now let's make it so that only the server is running this code and that it is only going to execute once. Now that we are done making the script, let's do the final touches. Let's add the GameObjects to the right references. Now make the font size bigger. And make the canvas scale with the screen size. Don't forget to save the scene because we will build it. We need to change to a windowed screen. I like 480 by 480. Open 3 instances of the build we just made. Put them side by side, then make one of them a server and the other 2 clients.